Good morning. Today we are doing a review of Chapter 5. And I'm just going to give you a heads up that this was a long chapter, so there are a couple problems in here that might take a little bit. They are word problems. But first we're going to review the three forms that we learned. Our first form that we learned is called slope-intercept form, or the form y equals mx plus b. Now you might be given 2 points in the form xy, or you might be given a function like f of x is a fancy way of saying y. So this is really x, and this is really y. So this point is really 3, negative 20, and this point is really 5, 8. So once we have those 2 points, we can find our slope, because we need to find our slope and our y-intercept. So I'm going to use my slope formula, y2 minus y1 over x2 minus x1. This is also on the wall in the classroom. And I'm going to label my points. This is xy my first point, xy my second point. So y2 minus y1, we have 8 minus a negative 20. That makes a positive. And then 5 minus 3 on the bottom. Well, 8 plus 20 is 28. 5 minus 3 is 2. So 28 divided by 2 should give us, well, 20 divided by 2 is 10. 8 divided by 2 is 4, so 14. That's our slope. But we also need to find b. Now, remember, we can find the point 0, comma b, but neither of these points have a 0 first, so we need to use our equation to find b instead. We learned that we can plug in everything we know except b to find b. So if I use this first point for y, y is, actually, I'm going to use the second point because these are smaller numbers. I don't want to use 20. It's a big number. I'm going to use 5, comma 8. And 8 is our y, so y is 8. Our slope is 14 times x, which is 5 right here, plus b, because we want to figure out what b is. So 14 times 5, I don't know what that is in my head, so I'm going to do double and half. Half of 14 is 7. Double 5 is 10. 7 times 5 is 70. All I did, because I didn't know what 14 times 5 was, as I took half of 14 and doubled 10. I taught you this at the beginning of the school year. 70 times 10 is 70. That was a lot easier to do in my head than 14 times 5, but you get the same answer. So, and then we have 8 here. And we want b by itself, so subtract 70. So we have b, and there are more negatives. 70 minus 8 would leave us with 62. Because 62 plus 8 more would give us 70. So there's b. It's a really big number, I know, but that's okay. And our equation, our final equation in the form y equals mx plus b, would be y equals our slope, which is 14x, plus b, and b is a negative 62. So it's not plus, it's really a minus 62. There's our equation, y equals mx plus b. Our second equation that we learned was called point-slope form, because we have a point that we plug in, x and y, and our slope, m. They gave us 2 points, so we can find our slope, x, y. There's our first point, second point, and we'll plug it into our slope formula, which is right here. So y2 minus y1, negative 7 minus a negative 19, that makes a positive. And then x2 minus x1, negative 2 minus 1. Well, 19 minus 7 gives us 12, or negative 7 plus 19, it's the same thing either way. And a negative 1 and a negative 2, they all are negatives, so that's a negative 3. 12 divided by negative 3 is negative 4. So our slope is negative 4. And we need to write in point-slope form. It doesn't matter which point you use. I would accept either. So if I use this first point, y minus y1, which is a negative 19, that makes a positive, equal to our slope, which is negative 4, and then x minus x1, and x1 is 1. Or you could have used the other point, y minus a negative 7, making a positive, equal to our slope, which is negative 4, and then x minus x1, which is 1. So either of these would be acceptable answers on your test. You don't have to write both. Oops, I made a mistake here. This isn't x minus 1, it's x minus x1. We use the second point, which is a negative 2. That made a positive. So be careful, like I said. So last form is called standard form, but we can't just write an equation in standard form. We can start with point-slope form or slope-intercept form and solve to get x and y on the same side of the equal sign. I have a point and a slope, so I'm going to start with point-slope form. Y minus y1, which is 3, equals our slope, 2/7, and then x minus x1, which is 7. I'm going to solve this to get rid of these parentheses. 2/7 times x is just 2/7 x. 2/7 times negative 7, if you're not sure, write it out. 2 times 7 is negative 14. 7 times 1 is 7. So negative 14 divided by 7 is just a negative 2. And then last, get rid of your 3, so add 3. We have y equals 2/7 x. There are more positives. There's one more. 3 minus 2 is 1. And that's now in slope-intercept form, but we want to get standard form. We want x and y on the same side, so I'm going to move this x over to the other side. Subtract 2/7 x. So I have a negative 2/7 x plus y equals 1. Now, this technically is an okay answer, but we don't like fractions in standard form, so I need to multiply this equation by the denominator of our fraction, which is a 7. So if I multiply this by 7, 7 over 7 cancels out and leaves us a negative 2x. Or if you multiply that out, again, it's negative 14 over 7, which is negative 2. All I did was multiply this by 7. Now y times 7 is just 7y, and 1 times 7 is 7. Alright, next we are going to graph this equation, but you do not need to solve for y. You could solve for y, but we're going to do it without solving for y, because this is really in the form y minus y1 equals our slope, x minus x1, or point-slope form. So we know our slope right here is 1/2, and then our point x and then y. Our point x first is 3, because the negative is part of the equation. But our point y here, it's not 6, because the negative is part of the equation, so another negative had to be with the 6 in order to get the positive. So first we're going to start by plotting this point. Be careful because they go by 2's. So first x is 3, 2 3's in the middle, and then negative 6, negative 2, negative 4, negative 6. And then our slope is rise 1, run 2. So rising 1 would be up in the middle here, and 2 to the right, 1, 2 is also in the middle, because these are going by 2's. If you went up 1 square and over 2 squares, that will give you the same slope. Up 1 over 2, or down 1 over 2. My points aren't super great, but they will form a nice straight line. Let's try the second one, same thing. The negative here, this is really a negative 1, so our slope is negative 1 over 1. And our point, xy, x is with the 2, but in order to get that positive, there would have to have been a negative and a negative, so x is negative 2, and y is just 7. So the point negative 2, 7 is right here. X is negative 2 first, and then up 7. And our slope is negative 1 over 1. So down 1 and 1 to the right. Down 1, 1 to the right. and draw your line. Double check to make sure that you have a negative slope. We'd be walking downhill, and that's exactly what this says, negative. Next, you are helping to plan an awards banquet for your school. You need to rent tables to seat 180 people total. Tables come in two sizes. Small tables seat 4 people, and large tables seat 6 people. Write an equation in standard form that models this situation. This is the only time we can write equations in standard form, when they give us two pieces of information and a total. We know total is going to seat 160 people. I'm going to say small tables are represented by X and large tables are represented by Y. So we don't know how many small tables, but we know they seat 4 people. So 4 people times the number of tables, X, would give us small, plus the number of large tables. There's 6 people at each, but we don't know how many. So I'm going to say times Y, the number of large tables. So X plus Y would give us 180. Now it says find the intercepts of the graph of the equation. This is finding our x-intercept when y is 0, and our y-intercept, which is when x is 0. Reminder, we did this way back in chapter 4 as well, when we found our x and y-intercepts. This is y, this is x. Because wherever it crosses my x-axis, that would be when y is at 0. Wherever I cross my y-axis, that would be when x is at 0. And I don't know if those are accurate, so let's wait to graph them till we find what they are. So first I'm going to plug in when y is 0. So 4x plus 6 times 0 would just be 0, so I'm not going to write that, equals 180. So divide by 4. 180 divided by 4 gives us 45. And then my y-intercept is when x is 0. So now plugging in when x is 0, anything times 0 is 0. So we have 6y equals 180. And then divide by 6. Well, 18 divided by 6 is 3, so 180 divided by 6 is 30. So x is 45 and y is 30. This isn't a point. If you wanted to think of it at a point, this point would be 0, 30, and this point would be 45, 0 in terms of x and y. These are separate pieces of information. This 45 is just telling us where we're crossing the x-axis. So in order to take up as much of my graph as possible, I'm going to say every other line is 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. Same thing going up this way. This would be 5, 10, just so that I'm using more of the graph. I'm going to erase this point or just move it here for a second. Oops, 25, 30, 35, 40, and that should be high enough. So this point, x is 45 right here, and then y is 30 right here. Again, if you want to think of those as points 0, 30, or 45, 0, you can. And then draw your line through it. Use a straight edge to draw a nice line. And then it says give 3 possible combinations of small and large tables. Well, this is one combination, 45, 0, because x is the number of small tables and y is the number of large tables. So this would be 45 small and 0 large. This is also a combination, 0, 30. There would be 0 small and 30 large. But we need another combination of small and large tables that we could use. You can follow your line to find a nice point where it crosses at a nice whole number. I'm just going to highlight a few here that would work well. Maybe that point as well. So it doesn't matter which you choose. If I want to pick this one, this would be about 22, you know, this one is not super nice. I would try to pick one that lands on a nice even number that we have labeled on our x or y axis. So for example, this one would be 30 small tables and 10 large. So that would be 30, 10. So here are 1, 2, 3 combinations. Next, we learn how to do parallel and perpendicular lines. It says write an equation of the line that passes through the given point and is parallel to this line. Well, the only thing we need from this line is the slope, because in order for it to be parallel, they have to have the same slope. So I'm just going to solve this for y to find my slope, and then use my point to write a new equation. So I'm going to first subtract 2x. So we have 9y equals negative 2x plus 12. And then the opposite of multiplying is divide. Negative 2 over 9 is just negative 2 over 9x. 12 over 9, I'm just going to leave it as 12 over 9 because I don't really need my y-intercept. All I need to know is my m, my slope, right here, negative 2/9. So my slope, my parallel slope, is also negative 2/9 because parallel lines have the same slope. So I'm going to use this point, xy, and my slope to write a new equation over here. Because I have a point in the slope, I'm going to start with point-slope form. So y minus y1, which is a negative 2, that makes a positive, equal to our slope, which is negative 2/9, and then x minus x1, which is 15. Let's get rid of these parentheses by distributing. Negative 2/9 times x is negative 2/9 x. A negative times a negative I know is going to be a positive. If I want to plug this into my calculator, negative 2/9, I would plug in negative 2 divided by 9 in parentheses. And then times a negative 15 gives me a positive 3.3 repeating, or 3 1/3. And then subtract 2 to get y by itself. Y equals negative 2/9 x. Plus, there's more positives, 3 minus 2 is 1, and we have the point 3. So that would be our equation. Let's do the same thing here, but with perpendicular lines. Remember, slopes that are perpendicular have slopes, lines that are perpendicular have slopes that are opposite, meaning negative and positive, and reciprocals, meaning our fraction is flipped. So in order to find our slope, we need to solve for y. So I'm going to move this x, subtract 3x over to the other side. So we have negative 2y. Write your x's first, negative 3x minus 4. And then last, the opposite of multiplying by 2 is dividing. And it's negative, so make sure to include that negative. 2 over 2 is just 1. We know two negatives make a positive. 3 over 2 is still just 3 over 2x. And here again, two negatives make a positive. 4 divided by 2 is 2. So that's our equation, but if we want a slope that's perpendicular, instead of a positive, we would want a negative. Instead of 3 over 2, our slope has to be 2 over 3. So here's our point, xy, and we're going to plug our point in our slope in to write a new equation, just like we did last time. I'm going to use point-slope form because we have a point in the slope. So y minus y1, which is 12, equal to our slope, which is negative 2/3. This is our new perpendicular slope we're using. And then x minus x1, which is 13. So let's distribute those. And negative 2/3 times 13, a negative times a negative I know is a positive. But I'm going to plug it in anyways. Negative 2/3 times negative 13 gives me 8.6 repeating, or 8 2/3. And then last, we need to add 12 to get the y all by itself. So we have negative 2/3 x. And then 8 plus 12 is 20, and we have the 0.6. So this would be the answer I'm looking for. Usually you won't get a weird decimal like we did on these, but for these ones, that's just what happened. Let's flip over. This one shouldn't be too long. It says determine which lines, if any, are parallel or perpendicular. In order to do this, we need to find our slope, or solve for y first, because we can't find our slope unless you have the form y equals mx plus b, or point slope form, because you can see m in both of these equations. So I'm going to solve this one for y. So first I'm going to subtract 4x. So we have negative 3y equals, I don't have enough room there, so I'm going to write negative 4x plus 2. And then divide everything by negative 3. Two negatives here make a positive, 4 over 3x. And then a negative here, 2 over 3. I don't really care about the 2 over 3. All I need to know about this equation is the slope. And my slope is 4/3. Let's find our slopes in our other two equations. This one is not solved for y, but instead of moving everything over, I'm just going to move the y over to the other side. Because we just need y by itself. We have our x's first, and then negative 4y, because 0 is just 0. So let's get y by itself, divide by negative 4. We have y equals negative 3 over 4x. Again, it doesn't matter if you put the negative on the top or the bottom, the answer is still negative. And here, 8 divided by negative 4 is negative 2. So our slope in this equation, in front of the x, is negative 3 over 4. Right now, these are not parallel, but they could be perpendicular. In order to be perpendicular, our slopes have to be opposites, negative, positive, which they are, and reciprocals, 4/3, 3/4. So right now I know A is perpendicular to B, but I need to look at C as well, because line C could be parallel or perpendicular to either one of these. And this one, our slope, we don't even need to solve this, because this is in the form point slope form. Our slope is 3/4. So this one, 3 over 4, is not opposite of line A. It is opposite of line B, but they're the same. 3/4 and negative 3/4. Those are not perpendicular or parallel. So this is our only answer. Our next problem says the table shows a living space recommended for pigs of certain weights. So we're going to have to make a scatter plot, write an equation, and then predict using our equation how much a living space a pig should need that weighs 250 pounds. So first I'm going to plot my points and make my scatter plot. On my x-axis here, I need to go from 40 up to 230. So I'm going to go starting at 0, maybe by, let's go by 20s. I'm only going to list every other one. Actually, we'll list them all. 20, 40, 60, 80, 100, 120, 140, 160, 180. This is why it's tough to list all of them. Then we're at 200. So this line here is at 200. This one was at 100. And we need to get up to at least 230. So here's 220, and then 240. I'm going to stop there because that's as high as we need to go. On my y-axis, x and y, I need to only go up to 8. So I'm just going to do every other line is 1. 1, 2, 3, 4, 5, 6, 7, 8. We can go a little bit higher if we need. So let's plot all these points. On the x, we have the weight of the pig, and then on the y-axis, we have the area that they need in square feet. So plotting this first point, x is 40. So at 40, we're at 2.5. At 60, we're up to 3. At 80, we're at 3.5. 100, we're at 4, forming a nice straight line so far. At 120, we're up to 5. At 150, we're up to 6. So 140 and 160, 150 would be right in the middle. And then at 230, we're at 8. 240 would be our 230, would be right in the middle, up to 8. So they kind of form a nice straight line, but not entirely. So we do need to draw a line of best fit that goes approximately through these points. So I'm going to move my line just a little bit. There we go. So for the sake of this problem, I would suggest choosing the same points I do. For example, I'm going to choose this point because I went right through that point, and that point is 60, 3. And then maybe I also want to use this point because I would say I'm pretty close to that point, which is 120, 120, 5, xy. Let me write that again. Now the reason I use these points is because they are on my line. This one was not on my line, so I didn't use it, etc. So next we need to write an equation. We want an equation in the form y equals mx plus b. So I'm working on finding my slope right now, m. So let's count rise over run. When I count up this way though, I need to count every other line is 1, 2. So I'm rising 2. And I'm running, each one here is 20. 20, 40, 60. 2 over 60. And I can simplify that by dividing by 2. That would give me 1 over 30. So my slope is 1 over 30. And I'm going to use my point, I'm going to use this point, x and y, to plug in. I have a point and a slope, so instead of just using slope-intercept form, I'm going to start with point-slope form because I have a point and a slope. So plugging everything in, we would have y minus y1, which is 3, equal to our slope, which is 1/30, and then x minus x1, which is 60. So if I distribute this, 1/30 times 60 is still 1/30. 1/30 times negative 6, I'm going to type that in, 1 divided by 30 times negative 60 gives me, oh nice, a negative 2. And then we want y by itself, so I'm going to add 3 on both sides. And we get, I'm just going to write it over here, y equals 1 over 30x, and negative 2 plus 3 is a positive 1. And that makes sense because my line crosses almost at exactly 1. So there's my equation. And now it says about how much living space is recommended for a pig that weighs 250 pounds. Well, pounds weight is on my x-axis, so I'm going to plug in a 250. I could look at my equation to try and predict, whoa, that was not a straight line, to try and predict straight up to see where it is on my line here. But to get a more accurate answer, I'm just going to plug it into my equation. Y equals 1 over 30 times x, which is 250, plus 1. So let's plug in 1/30. It's not 1/3. 1 over 30 times 250. And I get about 8.3. And then we have to add the 1. So we have about 9.3. So a pig that weighs about 250 pounds should get about 9.3 square feet of space. So 9.3 by 9.3 by 9.3 to make a nice square pen for the pig. Last question. The table shows the federal outlays for agriculture in billions of dollars. So it's talking about money. From the year 2000 through the year 2004. First, let's make a scatter plot. Just like the last problem, here's my x and my y axes. And the reason why we're doing so many of these is because these are important. You might have one like this on your test. So the year 2000 would be the first year this is happening. It's been 0 years if it's been the year 2000. In 2001, that'd be 1 year since 2000, and so on. So on my x-axis, the number of years, I'm going to say the year 0. Every 2 lines I'm going to say is 1 year, just to take up more of the graph. And then I need to go all the way. If I look at my highest number is right here, about 36. So I'm going to go by 5s. Every other would be 5. 5, 10, 15, 20, 25, 30, 35, and 40. I've covered as much as I need to. And let's plot these. In year 0, we're at about 36.5, so here's 35. 36 is a little bit more. In year 1, we're at about 26. There's 25, 26. In year 2, 2002, we're at about 22. So there's 20, 25, so 22 would be about here. In year 2003, or year 3, we're also at about 22. And then in year 4, we're at about 15. There's 10. There's 15.4, maybe about there. So we need to write an equation. So I'm going to put a line through my data here, some above, some below. Maybe my equation will look something like that. So in order to write an equation, our next step, write an equation that models the federal outlays as a function. Equation, function, they just mean write an equation in the form y equals mx plus b. So in order to find our slope, we need 2 points. So let's pick 2 points on the line. I'm going to say this one's probably close enough. So x is 4, so in year 4, we're at 15. And then I'm going to add this point right there. That would be a nice point for me to maybe choose. And that's 2, 25. I picked that point because none of my other points were on the line. I couldn't use those. Okay? So let's count our slope. Find our slope. We're going to rise or go down. Every 2 lines here is 5, so we're going down 5, 10. So we're down 10. Or you could just do y2 minus y1. 25 minus 15 would give you 10. So we went down. And then here we're going over 1, 2, or 4 minus 2 would also give you 2. So 10 divided by 2 is 5, and it's negative. So there's our slope. So I'm going to use my point and my slope to write an equation. I'm going to use this point. If you want to use the other point, you can. So instead of using this, I'm going to use point slope, because that's what I have, a point and a slope. Y minus y1, which is 15. And then our slope is negative 5. And then x minus x1, which is 4. So let's distribute this. Negative 5 times x is just negative 5x. A negative times a negative makes a positive, and 5 times 4 is 20. And then add 15. Our equation would be y equals negative 5x, and 20 plus 15 is 35. So this one happened to be a nice number. You might have decimals if you picked different points. And then our last question, find the 0 of the function. 0 of a function means when f of x equals 0 or when y equals 0. So let's plug in when y is 0 and solve it. So the first subtract 35. We get negative 35 equal to negative 5x. And then divide by negative 5. I know I'm going a little bit quick, so feel free to stop the video if you need. Two negatives make a positive, and 35 divided by 5 is 7. So what does this mean? X is 7, so here's 5, 6, 7. So our graph, it should cross at 7 there. What does that mean? Well, looking at our y-axis, y was the number of federal outlays, or they're talking about money. When the amount of money on our y-axis has reached all the way down to 0, that was at the 7th year, since the year 2000. So this would really be the year 2007. So to explain this, you could say, in 2007, the federal outlays were at 0. Or when the federal outlays ran out, there's no money left. All right? So you do have homework, and it's just 1 through 18, all of them out of the book. It's a review assignment. I think it says chapter test on that page.